Hello everyone! What we will talk about next is power transfer and speed reduction mechanism. First, let's talk about gears. Before we begin talk about gears, let's talk about gears in history. In the beginning of its development, there were actually no teeth, such as the one shown on the left. It was driven by friction. It was probably a small wheel driving a bigger wheel. The reason why it's a small wheel driving a larger wheel is mostly because it will be required and used in a working saving mechanism. During its development, it was realized that this way was not convenient at all. Why was it not convenient? Because the transmission was not sure, so in order to make the transmission more reliable, the wheel on the right was created, which was known as a gear. Having teeth meant a closer and precise mesh, and its rotation will be better. What do we have to talk about friction wheel? Because it will be very important when we talk about the gear parameters. So I'm giving you the concept first. In the beginning of their development, gears did not have teeth and used friction. Later, we'll talk about the concept of the pitch circle, which began with the friction wheel. We'll talk about this more when we encounter it later on. Next, we'll talk about gear parameters. We will be drawing the gears ourselves, so we need to have a basic understanding of some of the gear parameters. The first one is the pitch circle. It is a friction wheel that we talked about just now. When two actual wheels are rotating, there's a point in which there's actual contact with the other wheel. We call this the pitch circle. The second one is the diameter of the pitch circle, which is called pitch diameter. The third concept we are going to explain is the module. It refers to the size of its teeth. There are two ways of dividing it. One is the module, and the other one is the diameter pitch, which is the PD formula. These two differ in that one represents the metric system, while the other one is for the imperial system. Both describe the size of the gear teeth. We use module more frequently. So let's check the module first. The module equals the pitch diameter divided by the number of gear teeth. So the larger the module, the bigger the teeth. What do different gear teeth sizes represent? It represents its force. You can understand that the smaller the gear. Basically, gear teeth are mostly defined by a whole number unless you use it in special application. When you're drawing the gear, you need to pay attention to this detail. Otherwise, you draw the gear and end up not being able to buy the gear of less size. Next, let's have a look. Why do we need gears? 1. To transmit power, which we mentioned before. 2. To change the speed. Change the speed also changes the torque. The faster the speed, the lower the torque. When we change its speed, as the speed slows down, the torque will increase. Third, to change its directionality. We will give some examples of gears to explain how to apply. Then, the first one is the spur gear. The spur gears have two parallel axles rotating. When these two gears are rotating, we can notice that the direction of rotation is opposite to each other as mentioned before. The gears will be reversed to each other, which is the purpose of a spur gear. There's no difference in size. There's no big gear with a small gear, so the speed and torque remains the same. However, when the gear profile changes, the torque will change as well. The second type is the rack. The type of motion of the rack is like this. When the gear rotates, it will drive the rack all the way around. When the gear moves, it will drive the gear. They can interchange the roles of driver and follower. If it is gear that drives the rack, it means that a circular motion is converted into a linear motion. What it changes is its direction of motion from a circular motion to linear motion. This is the function of the rack. The next one is the bevel gear. Let's take a look at the bevel gear. The motion of the bevel gear makes two motions, perpendicular to each other. They're similar to a spur gear that have axles parallel to each other, but let's change to be 90 degrees from each other. In certain spaces, we want to change the direction for 90 degrees directional change. We'll use the bevel gears. The last example we're going to see is the worm and wheel. The concept of worm and wheel is frequently used in robotics. Why? Because the worm can drive the wheel, but the wheel cannot drive the worm, which means it's irreversible. Let's take a look at the following picture. When the worm is rotating, it will drive the wheel below. But when the wheel is rotating, it cannot drive the worm. When our output shaft is the wheel, if there's something outside that's trying to force its opposite turning, it won't be able to do so. We call this phenomenon self-locking. Self-locking has its application when used in fixtures or in lifting mechanisms, so I introduce this to you. Next time when we encounter a practical example, I will give you full explanation. Let's keep going. When we're doing speed changes, it won't have much difference using just one set of gears. Why? Its speed ratio is related to the size of the driving and following gears. It cannot differ too much, or it will require a lot of space. That's why we use gear change. We combine many gears, and they take out less space. But the gear ratio, that is, the speed difference, can be large. So we frequently use gear change when working with this. Next, we'll talk about gear maintenance. When the gear is rotating, it needs lubrication. Why? There's a reason for that. First is that it can reduce the dynamic friction coefficient between two gears rotating. Secondly, it can reduce the heat generated from the sliding and rolling friction between the gears. It helps with the cool down of the gear surface, so when we're using motors, especially gear motors, you must consider that there are gears inside, so you need to add some lubrication. When we're using gearbox, they can be divided into two types. The first one is the plastic gear. When you're using plastic gears, remember that you should not apply grease or motor oil. You cannot use it like that. You should only use lubricants that are specifically used on plastic gears. This way, it won't cause the gears to dissolve. I've seen many people do this in the past. Because it's not easy to buy silicone oil or lubricant for plastic gears, you may have to go to some specialized shops to buy them. I've also seen people who play with model toys. They use Vaseline. After I use it for real, I realized that it's quite convenient because it's not easy to buy and gives the result. If you're not able to buy silicone oil, you can use Vaseline instead. Of course, this is not a regular method, but it is a method that is easy to acquire. But it is a more convenient method which you can apply grease or something similar to motor oil when you are using gears. You can add some lubrication. Next, we'll take a look at motors that are frequently seen. This is a TT motors that we frequently use. It uses compound gears. Why is it called compound gear? Within a gear trend, a single shaft can have two gears. This is called a compound gear. This is also applied to have larger gear speed ratio in applications with limited space, which only compound gears can be used. This is used to reduce the space utilized. This is a TT motor. What we will say next is that TT motors are used very frequently in small-sized self-propelled vehicles. The second type is the worm and wheel gear motor. When using this type of motor, as mentioned before, it is a very convenient motor with a self-locking function. When used in lifting mechanisms, since you're lifting an object, if it is too heavy, it may drop down. But if you use a worm and wheel gear motor, it won't have this problem. It's not possible to transfer any force from the wheel back to a worm, so it won't have this problem. The transmission of the worm and wheel gear motor, which compared to the other planar gears mentioned before, can easily achieve a high speed reduction. So it's quite useful in applications with little space but also require high torque. That's why the worm and wheel gear motor is frequently used in lifting mechanisms in robots. Next, we'll introduce you the planetary gear system. The planetary gear has one or more gears that turn around a fixed shaft, just like the planets orbiting around the sun. That's why it's given such a name. When this planetary gear system is working, it has the feature where all gears participate in the work. So when it's rotating, take this picture example. When it's rotating, there are probably 3 gears that are doing the output work. Therefore, each gear can withstand more workload. So it has a feature which is that it is suitable for heavy load applications. Secondly, it can easily provide a high-speed ratio in limited space. The planetary gear has these 2 features in its application. First, it is most suitable for heavy loads. Second, its torque is higher. These are the features of the planetary gear. After talking about gears and speed reduction mechanisms, next we'll talk about bearings. Why do we need to talk about bearings as seen in this picture? What you are seeing is the same. The motor's output shaft is actually a rotating shaft, but when it needs to fit with the speed reduction mechanism, a bearing is used between them to support its rotation. When choosing our motor, there is another kind of bearings called bushings. We'll encounter with their applications. However, the characteristics of these 2 are quite different, so I need to remind you when you use them. First, let's take a look at the uses of the bearings and bushings. They both are used in the supporting of the rotating shaft, bear the load of the shaft and keep the shaft centered. For their maintenance, they are lubricating oils specifically for bearings, but the school doesn't really use them because it's required to buy in bulk, so we usually use sewing machine oil that's very accessible. The sewing machine oil has the problem of evaporating due to friction. Motor oil is barely accessible, but motor oil can easily generate sludge and it gets dirty, so you have to clean it properly after each use. When using WD-40, the main function of the WD-40 is for rust removal and rust proofing. Its lubrication capabilities are not good. If your bearing or bushing gets dirty, you can spray a bit of WD-40. After cleaning it up, then add more oil to keep it lubricated. Some students may ask if it's okay not to use any lubrication. Of course it's not okay. Why? Because when lubrication is not good enough, the bearings and bushings can wear easily. With time, the shaft will shift. So you have to bear this in mind when buying. Generally speaking, motors with bearings are more expensive, and motors with bushings are cheaper. If you're using motors for high speed, speed reduction mechanism or heavier loads, you must buy motors with bearings. The results will be better. Bear this in mind. Next, let's have a look. Since we are talking about bearings, let's talk more in detail. In general, bearings are divided into 2 types. One is called radial bearing. When you're buying a bearing, you'll be asked to understand their basic dimension specs, which refers to its inner diameter, outer diameter, and its thickness. Generally, when we're buying bearings, there are these parameters. When you buy a bearing, other than using it on the rotating shaft of motors, some parts of the robotic arm have rotating shafts, so we will buy the bearing to install it in such places. Bearings are divided into 2 types. One is called radial bearing. The load it receives is perpendicular to its rotating axis, such as in here. We use a radial bearing. The other type of bearing is called thrust bearing. The thrust bearing is parallel to the direction of the shaft. It can withstand the whole load of the object. When working with the robotic arm for its left and right rotation, which is the part framed in red, we use thrust bearings. It can withstand its weight and keep its rotation centered. This is the application of the thrust bearing. Let's talk about the specs of motors and servos that are commonly used. Before talking about this, let's take a look at the speed reduction ratio. No matter if it's about motors or servos, the driver part is always the motor. In principle, motors have high speed and low torque. For actual applications, they don't meet our requirements. When we need to use this driving component, we usually need slower rotational speed and higher torque. So we usually use them along with speed reduction mechanisms. After leveraging them with speed reduction mechanism, there will be a speed reduction parameter. Let's talk about what speed reduction ratio is. is the transmission ratio of a speed reduction mechanism. It refers to a ratio between the speed and reduction mechanism's input and output speed. The goal is to achieve a suitable torque. Its formula is the input rotational speed divided by the output rotational speed, which equals to the follower gear's number of teeth divided by the driving gear's number of teeth. Let's move on to understand this definition. Let's take a look at a TT motor. This is a gear motor that we use frequently in self-propelled vehicles. We mostly use them for the motors in the chassis of the autonomous vehicle. These are the commonly used speeds: 48 to 1, 120 to 1, and 246 to 1. When making the autonomous vehicle for a moving platform, we usually use the 48 to 1 or the 120 to 1 ones. They differ in how much speed and torque you need. During the actual operation, I realized that the 41 to 1 motor speed is fast, but since its torque is lower, if your vehicle is overloaded when it starts up, it will require to rotate to a certain extent to output the required torque to make the vehicle move. So it will have a little setback. If the vehicle is heavy, the voltage needs to be increased to a certain extent. That is, the PMW value needs to be higher for it to start up. The 120 to 1 motor have enough torque, but its speed is not fast. So it will depend on your loading and make adjustments. The 256 to 1 motor is hardly being used. Why? Because its speed is too low. At 3 volts, it only makes 23 revolutions per minute. RPM means revolutions per minute, which is pretty slow. Compared to the 48 to 1 motor, it's 1/5 of its speed. Its speed is too slow, but its torque is pretty high, with high torque. It can be used in applications where it requires high torque output for the mechanism design. It depends on your own needs. Next, DC motors have a characteristic: their speed is related to the voltage. The higher the voltage, the higher its speed. Normally, the voltage used in TT motor do not exceed 12 volts. Mostly are between 6 volts and 9 volts. You may say that you want to achieve a high speed. Can you just increase the voltage? Of course not. Why? Because the motor itself has a heat resistance. When the voltage is too high, the current will increase, and heat will also increase, which can cause damages and make the motor burn out. Normally, we don't exceed its rated voltage. You must bear this in mind. The next spec is the torque. These torque values were obtained from several web pages, which is the result of overlapping data. Since the spec of the TT motor of every manufacturer is different, this data is for reference only. You can buy several motors and test out their speed and torque in different settings and see which one meets our needs, then buy more of the motor with the same spec. This is a more appropriate method. What we are going to see next is the servo. When using the servo, the 3 most common types are this: SG90, MG90, and MG995. MG995 and MG996 are very similar. Here you can see the voltage value and torque value used. The rotation speed is also quite different. If we are going to use a lighter load, using SG90 and MG90 is enough. If you need a heavy load, you can use the MG995, however, it still has a low limit. Next, we'll explain the characteristics of these torque values. Let's take a look at this. Next, we'll explain what torque is. The first unit in the metric system is Newton. However, when we buy these parts, such as the TT motor or the MG995, the label rarely shows the unit of Newton. It's usually labeled with kgf.cm. When we explain this later, we will use the most common unit method. If you find that the motor that you want to buy is labeled with Newton, you can use a unit conversion method to convert this. It depends on your own needs. Let's take a look at this. Let's give an example. Let's say that the servo we want to use is the MG90, and we are designing a lifting mechanism. We need to lift a gripping mechanism that weighs 20 grams. This mechanism also includes a grab object. What is the longest moment arm it can use? Checking the table from earlier, you can see that the MG90's torque is 1.8 kgf/cm. We're going to use the torque formula to solve this. Torque equals force multiplied by the moment arm, which will be assumed using x. The weight of the object it's grabbing is 20 grams, so we multiply it by 20. The servo's torque is 1.8 kgf/cm. So we need to convert this formula. We need to change kgm to g by multiplying by 1000. The last calculated is x equals 90 approximately. The unit is cm. When used in practical operations, you should be a bit more conservative and make this value smaller to less than 90 cm. This is a suitable arm's length.